Good morning, students. In the previous session of the chapter Sets, Relations and Functions, you have learnt some particular type of functions, that is one function, many one function, onto function, into function, bijective and also inverse of a function. Now in today's session also you are going to learn two new type of function. One is known as an identity function. Identity function. Here, if you take a function f defined on the set A, we say, defined on the set A, that is, it is the domain is also A, the codomain is also A. A function f from the set A onto the set A is said to be an identity function if f of x is equal to x for all x belonging to A. That is, each number would be associated with itself. In other words, image of each element is itself. That is, suppose you take the set like this. It will have more elements also. Now this is a set A, same set I am considering here. F is a function from set A to onto A. See, fx equal to x. When you give the value x equal to 1, what is f of 1 equal to 1? So 1 means, x means it belongs to A, fx means it belongs to A, in this case. So 1 is mapped onto 1, 2 is mapped onto 2, 3 is mapped onto 3, 4 is mapped onto 4. Here I have taken integer, it can be anything, any real number we say. So here each element will have its, the image would be itself. The image of each element is itself. So that is known as an identity function. Identity means same element would be associated, an element would be associated with itself. So we call it as an identity function. The next function is called a constant function. It is called a constant function. See, the names are given in such a way that by looking at the names, we can say what can be the definition of the function. A constant function means here, let me write the definition. A function f from the set A onto the set B is defined like this. F of x would be equal to some k for all x belonging to A. That means that any element you take from the set A, it will have only a common image k in the second set B. See, it can be x is some number here, need not be a particular number, not an integer like that I am saying. It can take any value. Suppose it is a real set we are considering. All the real values will be mapped onto a common element which is a constant. So that is, suppose this is set A, this is set B. F is a function from set. So suppose I am having 1, 2, 3, 4, 5 and here it may be say A, B, C, D. Now 1 will have the image C, 2 and all the elements will have a common image C. So we call it as a constant function. It can be anything here, C is some constant. Suppose there may be a number also in the second set. All the elements belonging to the domain will have the same image in this one, that is called as a constant function. Constant means the image of each and every element of the domain is a constant, so we call it as a constant function. So these are the different types of functions we have learnt under this particular topic, that is the types of function. So in the previous session you learnt about six types of functions. In this one we have learnt about two functions. One is identity, the other one is a constant function. Now another here in all these one, while defining or while working out the problems, now we had considered only one function at a time. That is, it may be f or g or h or whatever may be that one. Only one function at a time we had considered to define a new type of function or to define a function also. Now, I am considering a combination of two functions that is known as the composite function. It is known as a composite function. Composite function means, again, it is the word is a composite means we are combining. That means that there would be more than one function. Here we consider two different functions and combine them. When we combine them, how it would act, what would be the result, how it can be defined. So here I consider three sets here. I consider three sets. Set A, set B, set C. Let us assume from A to B a function f is defined, and then from B to C let me take g to be the function defined from B to C. So here from A to B f is a function from A to B. Let me write that one. F is a function from A to B and g is a function from B to C. Okay. First function is connecting A and B. Second one is connecting B and C. So, B is the common for both the functions here. Here B is the codomain, here B has become the domain. Now, here we define the combination of that one, that is, suppose you take an element belonging to x. When it is connected with y here, we write it as fx, isn't it? This notation you know already. If y belonging to B is associated with x belonging to A under the function f, we write it as y is equal to fx. Similarly, if y belonging to B is associated with z belonging to G, we can write it as g of y. Same notation. Here y equal to fx, here z would be equal to gy. But what is y here? Y is equal to fx. So here we can write like this, z is equal to g of y, but y is fx, it is g of f of x, and this is written as, this g we write like this, g o f, like this, g of y f of x we have written. No? When two functions are combined or composite function, we write it as g o f, some pronounce it as g circle f, we read it as g o f of x. So here see here f was a function, g was a function, f was another function. This is a combination of both of them. So here x is belonging to first set, z is belonging to third set. Therefore, from here to here, a function can be defined. So here if you take this element, no, here it is like this. So directly we are connecting the first element belonging to the first set with z belonging to the last set. So here to here it is GOF is from A to C. So we combining them, we write like this. It is the set the function GOF from the set A onto the set C. This is called as the composite function or composition of two functions. Okay. So here A to B we are having function f defined. From B to C we have defined the function g. So here from A to C the function GOF is defined. Now how does it act here? See, x belonging to A is associated with y belonging to B under f. Y belonging to B is associated with the z belonging to C under the function g. Therefore, we write y equal to fx and z would be gy. But what is y? Writing like this, it is z equal to GOF of x. That means that x belonging to the set A is associated with z belonging to C under the function GOF. So, f from A to B, g from B to C, then GOF is from B to GOF is from A to C. So this is called as the composite function. So generally we can write like this. So usually the definition is not asked in the examination. The problems have been asked on this one. That is, you write like this: F is from A to B, G is from B to C, then GOF is from A to B. Okay, GOF means first we operate F. So F is operated first, then G is operated. So GOF is actually, or you can write like this: GOF of X means G of F of X. So this is the meaning of that one. GOF of X means G of F of X. What do you mean by that one? First we find the value of Fx. That means we operate using the definition of F. Then whatever amount, whatever element we get here, on that one we apply the function G, depending upon how the function G is defined. So, or suppose it is in the reverse order, FOG, then it would be F of G of X. We apply G first, that is, suppose we are having like this, FOG of X. In that case, now it is F of G of X. That means first we operate Gx, whatever element we get on that one, we apply the function F and we will be getting some element. So these two are two different, we will not be getting the same element here. So on this particular topic, the problems have been asked here. So let us try to work out some problems. Now the problems are like this. Let me consider the first problem. If F of X is equal to X plus 1 and G of X is equal to X square plus 1, then find FOG of 1 and GOF of 1 FOG of 2 and GOF of 3. GOF of 3. Now one by one we will do the calculation. See, observe here, I have given FOG of 1, G, the number is same, but I am operating the functions in different order. Here FOG of 2, another number, same function, number is different, same function, the number is different. Carefully we will do the calculation one by one. First one, FOG of 1. Just now we gave the definition, it can be written as F of G of 1. FOG of X means F of G of X, F of G of 1. G of 1, what do you mean by that one? We have done such problems where we have calculated the value of the function. G of 1 means wherever X is there, you have to write the value 1. That means I can write it as, it is F of, how is function defined? 1 square plus 1, that is F of 2. Now come to the function. See, Fx is X plus 1 means F of 2 would be 2 plus 1, that would be equal to 3. So this is the value of F of G of 1. Then second one, G of F of 1. Now here, that means that first it is G of F of 1. That means that F would be operated first, then we will be operating G. Now go to the function F here. How F is defined here? It is F of 1 is 1 plus 1. 1 plus 1, that would be G of 2. G of 2. Come to the definition of this one. X would be mapped onto X square plus 1. 2 would be mapped onto 2 square plus 1, that is 4 plus 1, that would be equal to 5. So while writing you have to be careful, while copying the problem you have to be careful, because see, by just interchanging we will be getting different answers here. Now go to the third part, it is FOG of 2. The number is different. that is f of g of 2. Now come to the definition of this. G of 2 means x is x square plus 1. 2 would be 2 square plus 1. That is 2 square is 4, 4 plus 1, 5. So we got f of 5. F of 5, come to the function f here. 5, x means x plus 1. 5 means it is 5 plus 1, that would be equal to 6. Lastly, the fourth part is GOF of 3, number 3. That means G of f of 3. First go to the function f. F of x is x plus 1 means f of 3 is 3 plus 1. How much is 3 plus 1? It is 4. Therefore, go to this one. X becomes x square plus 1. 4 becomes 4 square plus 1. That would be 17. 16 plus 1, 17. So, this is the procedure we adopt to solve the problems. Now, let me consider another problem where we do the same type of calculation. Here, the definition of fx would be x minus 1, and the definition of gx would be 2x square minus 3. 2x square minus 3. Now, we have to calculate here FOG of 1 and then GOF of 2. GOF of 2. So, these two have to be calculated. Now, let us start with the basic definition of the two functions that have been given. It is nothing but arithmetical calculation, but you have to be careful about copying the correct problem. Here, if you interchange the letter here, you will be getting entirely different answers we have seen in the previous one. It is FOG of 1. That means that f of g of 1. Come to the function g. X has the image 2x square minus 3. When x is there, square it, multiply by 2, take out my 3 there. So, here in the place of x, what do you have there? 1. Therefore, you can write this as f of 2 into 1 square minus 3. 1 square is 1. 2 minus 3, that is minus 1. Now come to the definition of function fx. How is it defined? Each x's image x minus 1. In the place of x we are having minus 1, minus 1, minus 1, that would be equal to minus 2. Now come to the second part here. It is GOF of 2. That means it is G of f of 2. Now, g of f of 2 means, first we define the function f. See, x is there, x minus 1. In the place of x, what do I have? 2 here. So, it becomes 2 minus 1. 2 minus 1 is 1. So, g of 1. Go to the second one. It is 2 into 1 square minus 3. Hence, it is equal to minus 1. So, copy the problem correctly and according to that you solve the problem. That is very important because in PUC level we do not have any marks for the method of that one. So, you have to copy the problem correctly, you have to solve the problem correctly. See, sometimes now if you copy the problem in a wrong way, the method may be correct, but answer you do not get the proper answer and no mark would be allotted for that one. Now, another problem which is defined in differently. F of x equal to x and g of x equal to x cube plus 1. X cube plus 1. You have to calculate FOG of 1 and GOF of minus 1. FOG of plus 1, GOF of minus 1. So, here I am giving you the negative number. So, while substituting you have to be careful. First one, FOG of 1 is f of g of 1. So, go to the second function g. X is there, x cube plus 1. In the place of x we are having 1, 1 cube plus 1, 1 plus 1, 2. So it is f of 2. Go to this definition. Fx equal to x means f of 2 would be equal to 2. Just now I gave the identity function. Just now I defined f of x equal to x is called as an identity function. So 2 has got the image 2 itself. Now come to the second part of that one. It is GOF of minus 1. Be careful. Now G of f of minus 1. First let me write the definition. F of x equal to x means f of minus 1 would be equal to minus 1 itself. Now come to the definition of the g function. X would be mapped onto x cube plus 1. So minus would be mapped onto minus 1 the whole cube plus 1. What is minus 1 whole cube? It is an odd power. So it is minus 1, this is plus 1. So we are getting 0 in this case. So this is the value of the function, the composite function. FOG of 1 has got the value 2. GOF of minus 1 has got the value 0. So this is the method we adopt. Whatever may be the definitions of the functions f and g, you have to do the, especially the arithmetical calculation, you have to be careful. Now let us try another problem. F of x equal to 2x plus 1 and g of x equal to x square plus 2x plus 1. You have to find the value of FOG of 2 and GOF of 3. The numbers are little bit more, and the function is both of them are having more terms here. Carefully let us solve. Now consider the first part. FOG of 2. How do you write this one? F of g of 2. Correct? Now go to the function g. When x is there, it will be mapped onto x square plus 2x plus 1. Look at this one. X square plus 2x plus 1. I hope remember, it's an algebraic formula. If you take the perfect square, x plus 1 the whole square, if you expand you get x plus 1 whole square here, x square plus 2x plus 1. So either it could be given in this form or it could also be given as x plus 1 the whole square. Here of course they have given it separately. Therefore f of wherever x is there, write the value 2. That is 2 square plus 2 into 2 plus 1. So 2 square is 4. 2 2s are 4. 4 plus 4, 8. 8 plus 1, 9. Therefore it is f of 9. Now f of 9 means, go to this relation, this function. Here wherever x is there, it is multiplied by 2, 1 is added. When 9 is there, 9 into 2, 2 into 9 plus 1, 18 plus 1, that would be equal to 9. Now come to the other one. GOF of 3, that is G of f of 3. Correct? First we calculate f of 3. So when 3 is there, 2 into 3 plus 1, that is G of 2 into 3 plus 1. 2 3s are 6. 6 plus 1, 7. So it is G of 7. Come to the second function. When x is there, squared multiplied by 2, 1 is added. In the place of x I am having 7. 7 square plus 2 into 7 plus 1. 7 square is 49. 2 into 7, 14 plus 1. So when you add 9 plus 1, 10 plus 4, 14, 1 carried, 1 plus 1, 2, 2 plus 4, 6. So it is equal to 64. That is the value of the second composite function. Now one more problem I am going to work out. Fx equal to x square and gx equal to x plus 1. Gx equal to x plus 1. So we have to find out general composition of function. That means that they have not given any particular value. Find out GOF of x and FOG of x. In all the earlier problems, I had given you some number there, 1, -1, 2, 3 like that. So, you have to give the exact value, whereas here a general term, general element belonging to the domain is considered, and you have to find out how would be the composite function. Now, this is G of f of x according to the definition. First, let me write the definition of fx. Each x has been mapped onto x square. So, what is fx equal to? It is x square. See, writing the first part is always easier. To apply the second function, you have to be careful. Look at the second function. How it is defined? When x is there, 1 has been added to that one. Here, in the place of x, what you have? X square. So, whatever term is there, 1 has to be added to that one. That means it becomes x square plus 1. Now, come to this one. It is f of g of x. First, we consider the function. So, I told you again, whenever the composite function is there, applying the first part of the function is easier because it will be always there. For the second part, now look at the definition, according to that you have to apply. So, f of gx means it is x plus 1. Now, come to the definition of the first function. Each x has the image x square. So, whatever number is there, it has to be squared. In the place of x, what do you have here? X plus 1. That would be x plus 1 the whole square. Either you can write like this or you can do the expansion also. Even if you write like this, you get the marks for that one. See, I told you always, though the same letters are there, they are in different order. The values that we obtain here, when a particular value is given or a general value also has been considered, we do not get them equal to each other. Here GOF of x is x square plus 1, FOG of x is x square plus 2x plus 1. So, always you have to remember. Now, this is the procedure we adopt to find the values of the composite function. So, instead of applying one function, we take 3 sets and 2 functions would be separately applied. By combining, the first set would be associated with the first set would be connected with the last set. So, this is how we define the composite function, and this is how we work out the problems on this one. So, this completes the second chapter, sets, relations and functions. Now, in the coming sessions, you will be considering the next chapters. So, go through all of them properly. These functions, this topic is very important because in mathematics, when we consider different chapters, we will be considering some function or the other. It may be algebraic, trigonometric, logarithmic, exponential, many types of functions we will be considering, and unless you have a good knowledge of the function, the domain, the range, everything, we find difficult to follow whatever you will be taught in the coming sessions. So, we will meet in the coming session under different chapter. Thank you.